Alright, we're given the function p of x equals, or two functions, p of x equals 1 over the square root of x, and m of x equals x squared minus 36. We're asked to state the domain of each of the following using interval notation. So, we're going to do p of x divided by m of x, and then we're going to do p of m of x, and then the last one is m of p of x. So before we do anything, we really need to figure out what is the domain of these two functions here. Let's look at the p of x. So if I look at p of x, which is just 1 over square root of x, I'm concerned with my denominator here because this is where I would get possibly get a 0. And there's only one way I can get a 0 there, and that's if x equals 0. The other thing I need to look at is the square root, because we can only take the square root of positive numbers. So what does that mean? So that means x needs to be greater than 0, because or it could be equal to 0, greater or equal to 0. Square root of 0 is 0, square root of 1 is 1, and so on. However, if we look up here, it can't equal 0 because that would make it undefined. So my domain would be, for this particular function, it's got to be greater than 0. So in interval notation, actually it can't equal 0, so this needs to be a parenthesis. We're going to go to 0 and then to the right of 0. So that's telling me x can be greater than 0 but not equal to 0 all the way to infinity. And that's the domain of p of x. And then let's look at the m of x, which is x squared minus 36. And I'm looking here and I automatically think all real numbers unless I have a square root or an x or variable in the denominator. Well, here I don't have a square root or even root. I also don't have any denominators. So this would be all real numbers or negative infinity to positive infinity for my domain. So now that we have those, let's go ahead and look at what happens when I have p of x divided by m of x. Well, remember what our p of x was. That's 1 divided by square root of x over x squared minus 36. So there's x squared minus 36. Now we have a complex fraction, which is 1 over square root of x divided by x squared minus 36. And when I'm dividing, I'm actually multiplying by the reciprocal. So let's think of this as over 1. And so I would have 1 over square root of x times the reciprocal of the bottom, which is 1 over x squared minus 36. And then we can distribute here, just so we can simplify this a little bit. Or actually, we can just leave it, let's just leave it as square root of x times x squared minus 36. We can actually just leave it here because, again, I want to look at this denominator and figure out, well, what can my x's be and not be. So again, you think all real numbers. However, I've got a problem. We have x's in a denominator and we have a square root. So again, let's look at this. And we also know what our original functions were. Again, we had a square root there and a denominator. So it's definitely going to be very similar to what we found for our domain for this one, because the square root of 0 is 0, so it can't be 0, and it also can't be a negative. So I'm looking at this 0 to infinity. However, I've got one more thing here, and that's that x squared minus 36. So x squared minus 36, where will that equal 0? Well, that's x squared equals 36. I can extract the square root. So I get x equals plus or minus 6. So these would be two issues, because if I plug 6 in here, 6 squared is 36, 36 minus 6 is 0. If I plug negative 6 in here, sorry, over here, negative 6 here, I get 36 minus 36. So I also have to look at this. Okay, this cannot equal, because we don't want it to equal 0, plus 6 minus 36. So now the hard part is, how do I write this? Well, I always like to draw a number line. And let's look at what we have here. So we have a positive 6, we have a negative 6, and then there's my 0. I guess I could make this a little more. It should be right in between the two. So we already know we have to be greater than 0, because any negative numbers will give me a problem under this square root. The only problem is I can go, but then what happens when I get to 6? Because over here we can't have a positive 6. So we're going to stop there, and then we'll pick back up and go on to infinity. So how does this look as interval notation? I'm looking at 0 to 6, union with 6 to infinity. Okay, let's look at our next question here, which is P of m of x. So I'm doing a composition function. Okay. So this means wherever I have an x in my P function, I'm going to plug in my m of x function. So P of x squared minus 36. And this is 1 over the square root of x squared minus 36. And we need to know, well, what are our what's our domain? Again, I need to look at this as a denominator. I can't have 0 in the denominator. And I also can't have a negative underneath my square root. So let's look at what would give us x squared minus 36. And remember, it can't equal 0. And we really did this earlier. We extract a square root. And so I'm looking at x cannot be plus or minus 6. So that's one thing we need to refer, because that will give me 0 under here. We also need this x squared minus 36 must be greater than 0. And that's because of the square root. So again, I do x squared must be greater than 36. And when I extract this square root, I get x. Now, since this is an inequality, it's going to be a little different than at the equal sign. I'm going to have a greater than the positive 6, but then x is going to be less than negative 6. So I switch that sign with my negative. So what does that tell me? Let's look here. Let's say we have 6 and we have negative 6. So it's telling me here it cannot equal 6. We're in the square root, it could, but we're not even going to include 6 because it can't equal 0 because of the x squared minus 36. So 6 and negative 6 actually are out. But we need to figure out, what about, if it's less than 6? Well, this tells me it can be less than 6. And it can be greater than 6. It can't be in between the negative 6 and 6, because either I would get a negative under the square root, or if it actually equaled negative 6 or 6, I would get a 0, and the square root of 0 is 0 and would be undefined. So our interval would be from negative infinity to negative 6 parentheses, union with 6 to positive infinity. All right, and let's look at m of p of x. So this would be m, and we're going to substitute our p of x in for m. So that's 1 over square root of x. Now, remind you, this has now become my domain. So we have to remember what we originally got for the domain of 1 over square root of x. And so we're going to square, that's going to be 1 over square root of x squared minus 36. And this is going to be 1 squared is 1. Square root of x squared is x minus 36. And we really can't do any more with that. So right now, x can't be 0 because that would make that undefined. But we also have to remember what our original, if you go back and look at our original function, since this has now become the domain of this m of x here, I also need to exclude or to use its domain, which it says x had to be greater than 0, it looks like, and not equal to 0 because of the denominator. So our domain for this function is actually going to be 0 domain to infinity. And here was our domain, and here was our domain for that particular function. So sorry, I guess that got cut off a little bit. There we go. So this is our domain for C.